Hello, everybody. Good morning and good afternoon, wherever you are joining from. Today, we have a very exciting fireside chat. We'll wait for a few more seconds for people to join the Zoom call. Yeah, in the meantime, please let us know what you are looking forward to. We're going to be talking a lot about deploying GenAI applications. So we will be asking some poll questions on your screen. So please feel free to answer them. So that will inform us in terms of what, in general, industry is looking for in terms of the infrastructure around GenAI. Okay, so we are good to go. Welcome and thank you everybody for joining us today on the AI Explained on inference, guardrails, and observability of generative AI. I am Krishna Gade, founder CEO of Fiddler AI, and I'll be your host today. Please put your questions in the Q&A box at any time during the fireside chat. Today's session will also be recorded and sent to all the attendees after the session. And without further ado, we have a very special guest on today's AI Explained, that is Jonathan Cohen, VP of Applied Research at NVIDIA. Welcome, Jonathan.
Hi, good morning.
Good morning. Thank you so much for being on this show, Jonathan.
Yeah, my pleasure.
Awesome. So Jonathan is an engineering leader of the NeMo platform. He has incubated AI technology into products including NIMS, which is NVIDIA Inference Microservice, and he's worked on a lot of foundation models for human biology, and altogether spent about 14 years in NVIDIA in various different roles, and prior to that at Apple as well. So Jonathan, maybe for our viewers, NVIDIA, for many people, comes across as a GPU and hardware company. What is NIM and NeMo? These seem like software tools. Could you share what these are and how they fit into the NVIDIA AI strategy?
Yeah, thanks. That's a great question. So NVIDIA has always been a hardware and software company. We call ourselves an accelerated computing platform company, and computing platform means not just a chip, not just a computer, but a platform, everything you need to do your computing. So we've always included APIs and tools and acceleration. And in fact, the reason why our platform is so successful, has been so successful, and delivers so much value is precisely because optimizations and improvements you make at any level of the stack, they all multiply together. If the hardware is twice as efficient and then the software algorithm I use is twice as efficient, then cumulatively I had a 4x improvement, right? And that's how we always think about it, these full stack improvements. So NeMo is just, the latest in a long line of NVIDIA software platforms, kind of following this strategy. NeMo is our platform for accelerating the creation and operation of modern AI systems. You could call them, AI agents or generative AI or large language models. These aren't all synonyms exactly, but obviously they're all kind of in the same bucket. And I think of them as modern AI systems. Modern AI systems, touches a lot of things. So there's training large language models or foundation models. There's customizing existing models. So there's many great community models out there. For example, the Llama models for Meta. You might want to start with one of those models and then somehow customize it and fine tune it based on your own data. There's deploying these models. There's managing the life cycle of the deployment. I have a model. I need inferencing. I need to observe it in action. I need to log what it's doing. I need to take those logs and somehow, maybe evaluate good and bad examples, maybe have a human correct it when I made a mistake, turn this back into training data, retrain, redeploy. There's a complete, what we call flywheel, typically around any deployed AI system. And NeMo is the software that manages all of that. And so NeMo covers both some open source Python components that are basically PyTorch-based tools for training, fine-tuning, evaluation, and then also a microservices platform, which is, at this point, the only component of the microservices platform that's in general availability is NIMs, which stands for NVIDIA Inference Microservice. And NIM is a very simple idea. The idea of NIM is just take a model, whatever model, package it up behind an API server. So in the case of large language models, something that's, let's say, OpenAI completion endpoint, compatible API, or Llama Stack inference compatible, or whatever it is. So there's a little API service that makes it easy to talk to this model. Behind that service, you have highly optimized inference. So because it's NVIDIA, we're going to always give you the best performance, best throughput, best latency. And so we'll use technology like TensorRT or whatever the best technology is. And all the enterprise grade features like security, up to date with the latest CVEs and security patches, connections into logging and observability platforms, and that whole thing then is a container. So this is not a managed service. NVIDIA is not operating this as a service. We take all this code, we package it up in a container, and you can get that container and run it yourself. And so if you want to have you want to manage your own LLM inferencing endpoint, it's as simple as grab the container, Docker pull, Docker run. That's it. And you're up and running in a few minutes. And because it's portable, you can host it in any cloud. You can host it on-prem. You have control. You can host it geographically, or in terms of network topology, as close to whatever you need to host it as you want. You can host it in a VPC. You can host it in your own private infrastructure that's air-gapped, whatever you want. It's just a container. And I think that's a very powerful idea, and that's something that our customers really appreciate. Because if you think about, what are these models actually being used for? Increasingly, they're, to quote Jensen, our CEO, these are digital workers. They're these agents that are operating alongside humans at companies, doing things that humans, would be doing or could be doing, or helping humans do things, which means they have access to all the very sensitive data that our employees have access to. If it's in a healthcare setting, it might have access to, or you'd want it to have access to medical data, or you'd want it to have access to proprietary company data, whatever it is. And oftentimes for this most sensitive data, controlling where that data goes and where it gets sent and who might be looking at it and storing is really important to customers. And so being able to have total control over how you deploy these things, where you deploy them, what you do with the data that gets sent, what you do with the logs, or maybe you don't log, or whatever it is, or where you run your observability, all these things is I think very compelling to our customers. And so that's the idea behind NIM.
Absolutely. This is great. So you touched upon a bunch of things, right? One of the things that I heard Jensen and even you talk about is this NIM as model in a briefcase. Essentially, it's like a large language model packaged into this container, and where you can go and run and deploy in your favorite cloud environment. So how does it work? For example, let's say, if I'm a customer running, my workloads are in Amazon or Google Cloud, how do I, what are the advantages of using NIM? How do I use NIMs for my, large language model inferencing?
Yeah, so it's all NIM needs is a Kubernetes environment. So anywhere where you can, and you could probably make it work even in a non-Kubernetes environment, as long as it's some kind of container orchestration. But let's just say, for simplicity, Kubernetes. So anywhere where you can orchestrate and launch containers, and a NIM is just a container. That's what makes it so simple. When people say, "Oh, it's a model in a briefcase," what they mean is it's not our model that we're holding for you. We give it to you, digitally, and you're free to move it to wherever you like. So any cloud. Now, you need a GPU, you need some accelerated computing hardware to run a NIM. The software stack that's in a NIM today is GPU accelerated. But as long as you have a Kubernetes environment that can orchestrate containers, that has access to GPUs, you can run a NIM. Not all NIMs will fit on all GPUs. They have memory requirements. If you want to run Llama 405B, that's a very large model. It's not going to fit on, a small GPU in some cloud somewhere. So there's requirements like that. But other than the physical requirements around memory, you can do whatever you'd like with a NIM.
Mhm. And so do you offer like prepackaged NIMs with like say Llama or Mistral, like
Exactly.
where you can download the containers and run it on your Kubernetes
Yeah, that's
environment?
exactly right. So we have a catalog. If you go to build.nvidia.com,
Mhm.
you can see the complete catalog of all of the models that we have NIMified.
Mhm.
In that process, we have something internally we call the NIM factory.
Mhm.
And what NIM factory does is we take these models when they get launched, or in some cases we know about them shortly before they're launched, and we put them through this process where we pre-build optimized TensorRT engines. We measure them. So we do all the like hardware level optimization. We make sure they work. We certify them across different hardware SKUs that we have. We package it and then we put it on this build.nvidia.com. And so you can try and you can interact with NIMs. NIMs are not just large language models. We have NIMs for, the concept applies to any model that you may want to inference.
Even computer vision models and things like that.
Absolutely. Computer vision, image generation models. We have speech recognition models as NIMs. We have biology models as NIMs, protein language models, molecular docking models, all kinds of things are as NIMs. And for many of those NIMs, you can download them yourself. So on build.nvidia.com, if it says run anywhere, that means that it's a model that's been packaged and we've tested it well enough that you can actually download it, and we guarantee some level of quality that it should run with low latency and high throughput and accuracy wherever you.
Awesome. So now, so I have like gotten a hold of a NIM server, maybe like Llama server. So I've deployed a bunch of containers now. Now I want to, as an enterprise, I want to make sure that I'm taking care of all the security issues and the things that you touched upon. I have maybe my healthcare records, and how do I, as an enterprise company, solve some of these security challenges when deploying these LLMs, right? How can Guardrails be customized to address these, and where would some of the NeMo framework help me?
Yeah, so the answer depends a lot on how you're deploying it. So not everything that you deploy, not every large language model, let's say, that you deploy is actually going to be used as a chatbot, right? Some of them may be very internal endpoints that are doing some very specific task. And so the security, the attack surface or the anomaly detection, these kinds of things, they may be harder or easier depending on your actual use case and deployment scenario. But let's just pick an example. Let's say I have the simplest, most obvious example, a kind of customer service, customer-facing customer service chatbot that I built. Okay, now I have I have this probabilistic AI system that I'm exposing to the public. I think probably everybody has seen by now news stories, that sort of trickle out about companies that have deployed these, and the customer talks the chatbot into offering it a discount or something like that, right? And now suddenly I have this problem where this digital representative of my company has done something against my company policy, and so this is a good example of the challenges and the risks of deploying AI models. I always think about it, just the analogy with a human. So if I had a human customer service worker, I give them a book. I tell them, what are our policies? What's our refund policy? How do you handle a rude customer? How do you handle an irate customer, right? We train our humans, we train people, we do all these things. And sometimes people get it wrong, and this quality assurance, and this is why whenever you call a line, it says, this call may be monitored for quality assurance purposes. That's what they're talking about. They do record these lines, and supervisors listen in, and they review calls, and they constantly training their staff, right? Why would you expect the digital worker to be any different, right? So when I'm interacting with a digital worker, I certainly want to be able to monitor what it's saying, monitor what the people are saying. That's on the monitoring side, but I also want to somehow control and constrain what this AI is doing. For example, I say, you are a customer service chatbot that is only to talk about product quality issues with our products. Don't talk about politics. Don't offer your opinion about what's the best wine, whatever it may be. Especially when this chatbot is based on a modern large language model, these models are incredibly sophisticated, able to carry on conversations about all sorts of things, perform many tasks. But that's not what you want, right? You typically want to highly constrain the domain, what you might call the ODD, the operational design domain, in which this chatbot is actually going to operate. So we have a product. I mean, there's many solutions out there. From NVIDIA, we've developed this technology we call NeMo Guardrails, which is specifically designed to do this. And the way NeMo Guardrails works is it's actually built on top of a very sophisticated technology. It kind of hides a lot of the underlying sophistication, but there's a very sophisticated technology called Colang, not to be confused with Golang, so Colang. And Colang is a dialogue modeling language, and Colang is incredibly powerful. But essentially, in Colang, you can describe using this specific modeling language the structure of a dialogue, of a conversation. You can talk about the topics that you would want to cover, the tone, and you can write triggers. So, for example, you can say if the customer says something in an angry tone, then trigger some rule, like make sure the bot responds in a very conciliatory tone. If the customer says something rude, and let's say the customer says something rude 5 times in a row without making any substantive actual request, then maybe your bot would go into some predefined, hey, I can tell that you're really upset. Why don't I disconnect today, and we can reconnect in the future, right? So whatever rule you may have, you can essentially, in Colang, you can describe these very complicated and potentially sophisticated rules. We also have a lot of pre-built rules, so you have to know all this, right? And one of the things that we're working towards before we release it for general availability is, the open source toolkit is available today, but we're working on a microservice version of this, and what we're working on there is really to have a bunch of these pre-built best practices to make it easy to deploy. But Guardrails also can, for example, look for prompt injection attacks or different security vulnerabilities or jailbreak attempts and all these things that are also kind of security issues. It's this very interesting world where security and dialogue management are kind of overlapping for the first time ever. One way I like to think about it is, in the past, when you think about computer security, you think about an API. I mean, really, security is all about APIs. I have an API, I have some way of communicating with the computing system.
So it's much more structured, but now anything
structured,
can be
right?
Through your,
and security flaws, security holes are some way of accessing that API in a way the developer didn't intend, that can get the system to do something the developer didn't intend it to be able to do through that API. Leaking information or granting permissions or whatever it is. This is kind of what computer security is really built around, this notion of APIs and access. And now we're doing this, we're putting this conversational engine in front of an API. So I can talk to a chatbot that has a human-like conversation with me, and then the chatbot's translating what I'm saying into calls to some more structured API behind the scenes. But now my conversation itself is the attack surface.
Correct.
And an attack might look like trying to convince a chatbot to do something it's not supposed to do. Which is very
there are these dude attacks and do anything attacks, Dan attacks that are
exactly. They don't look like computer security attacks of the past, right? And so there's a very interesting overlap between computer security and dialogue modeling. And NeMo Guardrails is really trying to embrace that. And so that's why the core technology is actually a dialogue modeling system. And then we layer on top of that a number of computer security concepts and techniques.
So on that, right? So the Guardrails seems like a rules engine framework. It's almost like a
fuzzy rules engine.
Fuzzy rules.
Kind of a dialogue-based rules engine. Right? I think that's
now, if I'm saying that, okay, if the user is abusing or if there is a jailbreaking attack, how is that detection capability happening? Are you actually using language models behind the scenes or other AI techniques to detect, if this is a jailbreaking attack or something?
So Guardrails is actually relatively agnostic about it. The software is relatively agnostic about this, and it relies on access to existing models. So, for example, you could have a jailbreak detection model, but given an utterance, is this likely to be a jailbreak or not? We have topic models that look at, again, a conversation and decide what give it a bunch of options, which topic most quickly matches, it also can sort of generally use large language models to do these sort of assessments, like what is the tone of this conversation or whatever it is. But the power of NeMo Guardrails, in fact, is whatever model you have that you want to use as part of your guardrailing system, NeMo Guardrails can call. It's very easy for NeMo Guardrails to become an orchestrator of existing techniques you have. So I have a jailbreak detection technique that I've developed, or
you can bring your own jailbreak detection model,
whatever,
or other APIs that you can integrate
That's
within
right.
Guardrails.
And we've developed some, but in fact, the way I would recommend you deploy NeMo Guardrails is to use Llama Guard for this, and there's a huge community of these models out there. In fact, that was the original design of NeMo Guardrails. Was based on this idea, like NVIDIA is not going to solve the guardrailing problem. This is like an immense problem. It's like saying we're going to solve computer security. Of course we're not. There's a huge community of people working on this. So from the very beginning, we thought it was really important to be able to tap into that and to provide a technology that maybe had some of our own techniques inside, but fundamentally was more of an orchestrator of the community's techniques as they're being developed.
Yeah, like for example, we have integrated within Guardrails so that Fiddler's intelligence techniques can be available for Guardrail. So,
and actually, just a comment about that. The other really important part of Guardrails is logging and monitoring. The NeMo Guardrails itself doesn't really do that, right? It's kind of a rules engine, as you say, and more sophisticated maybe than a simple rules engine, but it's a rules engine. But you also really want to be able to have something that's monitoring it, looking for anomalies, dashboards, all these kinds of things. That's not what NeMo Guardrails does. You could think of NeMo Guardrails as kind of more of an endpoint monitoring like node, but you really are going to want to connect it into some larger platform like Fiddler.
Right. Makes sense. And so when it comes to like runtime deployments of AI, one of the design patterns that we are seeing is in enterprises, they're building this gateway service, almost like a brokerage service that calls into many of the LLM endpoints. So there's almost like a model garden that evolves, for different use cases. And the gateway service federates requests back in the day. So it seems like a guardrailing framework could really help you build a really powerful gateway, right? So have you seen examples of customers?
Yeah, you certainly can do things like that. You can also choose to use some other system. So there's a lot of these, I think what people would now call like agentic AI systems, or compound AI systems. I think they're kind of synonyms in a lot of ways, where you again have multiple AI models that are interacting. NeMo Guardrails could be used that way, but you don't have to. You can build your software on, let's say, LangChain or something like that, or whatever platform you want, and still connect it into something like NeMo Guardrails and connect it into NIMs. And again, I think that the concept of NeMo, just the broader platform, is NeMo is not monolithic. It is very carefully designed to be a set of modular, independent microservices. Now, we design them all so they work well together. But you can say, I'm going to use NIM, and I want to use my own monitoring, my own guardrails, my own fine-tuning, my own deployment. That's fine. NIM's just a microservice, right? You can connect it into whatever. Or you can say, I want to use NIM and NeMo Guardrails, but I want to use my own, toxicity detection models, and I want to use my own whatever. That's fine too. It's really designed. It's explicitly designed to be something where you don't have to embrace the whole platform. You can take
basically it's a bunch of Lego blocks, and you can pick and choose whatever you want to.
Or you can embrace the whole platform, because the whole platform, has been designed with some kind of coherent vision about how you're going to build and deploy these systems. But if you have an existing agentic platform that you're using, and you like this one model and you want to deploy it with a NIM, that's fine too. Or, I have, let's say, many models interacting, and I already have some guardrails that are working for me, but I want to add, Llama 405B with guardrails, and you like the guardrails, the configurations that we provide, you can use that too. So it really is very flexible in that sense. That was a very important design point for us.
So maybe switching gears, right? So we talked a little bit about evaluation and observability of these generative applications. Do you see like these techniques of evaluation and monitoring differ from domains? Like, so there's a question from the audience, how does it differ from healthcare LLM apps to like financial services LLM apps? What's like, what sort of advice or guidance that you can provide, when
Well, I guess it depends what you mean by evaluation. So let me answer that in two ways. So one level of evaluation is this kind of monitoring. I'm looking for a problem. The kinds of problems that you might have are extremely domain dependent.
Yep.
Right. So in healthcare, I might have a monitor that's specifically looking for PII leakage. You know, I've designed my system so that it should never happen, but I want to just add another layer of security there where, hey, if the guardrail, if the chatbot ever provides PII that's not linked to the current patient, then flag that. That would be a guardrail, an evaluation, an online evaluation that would probably make a lot of sense in like a healthcare setting, right? Or compliance, in finance, I have a lot of rules about what information I can and can't include, or, this conversation is not allowed to talk about this, or we have an internal example at NVIDIA we've been working towards for a long time, which is an HR benefits chatbot that can answer questions about benefits. And there's a lot of things that you're just not allowed to answer. You say, in what stock should I invest my 401k? You can't, your HR business partner can't answer that question for you, right? So the HR benefits chatbot shouldn't answer questions like that. And again, you'll program it that way. You might fine tune it and provide it, some guidelines, whatever, not to do that. But you probably also want to add a guardrail and also a monitor to check for, are people asking these kinds of questions? What percentage of the time that someone asks a question that we're not supposed to answer, are we actually answering it? Is there a sudden spike in people asking inappropriate questions? Whatever it is, right? So there's like a real-time evaluation that I think is very context specific. The other way I could answer that question, though, just in general, is you want to evaluate your system. How accurate is it?
Yep.
System evaluation. So this is more like offline. I built a model, and before I deploy it, let's say, I want to just know how good is it. And that is also extremely domain specific. It's a use case specific. And I think this is a great example of, how I think about AIs is, general AIs are great, but I think most business use cases are not generic. I don't want an AI that is going to opine about, religion and history and whatever. I want an AI that does this one task, takes receipts and my reimbursement policy and the requested reimbursement and checks that this receipt matches this reimbursement policy, this receipt with this requested reimbursement matches my policy. I want an AI that just does that. I don't want it to tell me about, the history of the French Revolution or whatever, right? And therefore my evaluation is also going to be extremely task specific. And the way you're going to build your AI is you're going to first very clearly define your task. You're going to probably collect a lot of training samples. You have probably lots of human experts at doing that, because a lot of people have been doing these rote tasks for a long time. Probably have a lot of data collected over the years that you could turn into training data. Some of it is going to use to train, some is going to use for evaluation. And so that's why I say there's sort of two ways to answer this question. I think they're both very important, and they're both, in fact, quite domain specific.
Yep. So this is an interesting thing, right? So when it comes to, I used to work on search before, and we would have human raters that evaluate if the search quality was good or bad. And so now there are companies that employ red teams to do this, to sort of give you the domain specific answers. But how do you think the field will mature? So there is now this approach of LLM as a judge to use as an evaluator. What's the future here? How do you think the evaluation? Because there's scale that we are talking about, right? As GenAI hits scale, now you have lots of things to evaluate and observe. What's the future technology here?
Well, I think LLM as a judge, as people call it, makes a ton of sense. And I think what you're doing there is you're sort of saying, well, it's probably less accurate than a human, but I can evaluate way more. And so I'm going to trade off, volume of evaluation for quality, and that on balance, that's probably a good trade. And I think there's a lot of evidence that is true. I think there's still kind of a gold standard of humans evaluating, and I don't think we have any AIs that are as good as humans at evaluating responses. You have these things like Chatbot Arena, which are fundamentally humans. The interesting thing about Chatbot Arena, as a good example, is humans have biases. So chatbot arena is where you can go and anyone can go play with it, and you ask questions and a bunch of different chatbots answer, and you rate, you know, how well you like the answers. And so this is kind of considered like the gold standard for how good is your chat. But you know, humans have preferences. We like friendly tone that's not overly pedantic. That's, you know, the answer's long enough but not too long, and it's helpful. All these kinds of things, right? And so chatbot arena, you know, strongly selects for these things that people like. Is that a better chatbot? I don't know. You know, it's kind of subjective, right? So I think there's sort of strengths and weaknesses to humans and LLMs as a judge. The other thing I would say is not all large language models are equally good judges.
Right.
And you can build large language models that are specifically good judges. And you can fine tune and improve your large language model as a judge for a particular task. And so I think, and it, you can, you know, if you think of the analogy of a large language model, it's like a person. Again, I'm not trying to anthropomorphize the technology, but I think it's helpful to think about it this way. You know, some people are better teachers than other people. Some people are better judges. You know, some people are better at grading papers than other people. You know, like a high school history teacher who grades papers all day long is probably a lot better at grading history papers than I would be. And so LLMs, you know, you can make them better or worse at things. And so I think the future of LLM as a judge is, I mean, they're going to be used for lots of judging, but I think we will continue refining our techniques for building better AIs that are better at being judges.
Yeah. So far we've talked about guardrailing and monitoring in the context of accuracy and security, right? You know, you want to make sure that your GenAI app is accurate. You know, you mentioned examples of HR chatbot, you know, sticking to what it needs to do and filtering out other things, or like security issues where, you know, eliminate PII from showing up in responses. But then there's a whole gamut of things, you know, ethical considerations that, you know, people talk about. You know, I've seen Jensen go on stage talk about responsible AI and AI safety quite a few times, and then there is a legal aspects of it. You know, as countries and continents come up with regulations. There's this, you know, who owns the liability? You know, is the developer of the large language model or deployer? There's like a lot of these considerations here. And then if you are providing the guardrails, you know, would the guardrail provider own the liability? So there's lots of these implications here, right? So how do you think about it? You know, when in a company, especially in regulated sectors, Fiddler works with a lot of regulated customers. Some of them might be on this call. How do they think about the responsible AI aspects of generative AI, and will some of these tools, you know, help with them?
That's a complicated question. You know, I think, how do you think about the responsibility of your employees? And in a future where you have human employees and digital employees, you're responsible for the behavior and the processes and the policies of both of them. I think what's important is that you have some confidence that your digital employees are actually following your policies. That one, you know that you have a technique for explaining to your digital employees, you know, let's say in quotes, explaining to your digital employees what your policies are. So we have techniques for explaining to our human employees what our policies are, right? Training manuals. I know, I think legally we all have to do our sexual harassment training every 2 years. And NVIDIA has a code of conduct, and I have to retake my code of conduct training. You know, and it's like a little 30-minute like training course designed by, you know, someone in the legal department somewhere, right? I mean, this is like the whole industry, there's companies whose business is like helping enterprises train their employees in their own policies, right? And like we were talking earlier about in call centers, you have quality assurance, and again, whole businesses whose business is helping companies enforce quality assurance or implement quality assurance plans and enforce the level of quality and all this kind of stuff, right? The same thing has to happen for your AI workers. How do I train my AI? How do I teach my AI my corporate values? How do I ensure that it's complying with all the relevant regulations? All these are difficult things to do, and you know, we have some techniques for it today. We will continue refining those techniques. You know, and I think it's always a trade-off between, let's say, the ease with which you can constrain your AI
Yeah.
versus the quality and intelligence of an AI. So let me give you an example. I can have something that's not an AI at all. It's just a straight up traditional dialogue system with hard-coded responses and dialogue trees. I am 100% confident it will never say anything that I don't want it to say, because I literally wrote every line that it will ever respond to. This is like your old school. Old school is
Decision
years
tree based,
ago.
yeah,
Decision
exactly.
trees and state machines and all this is like well understood technology. Typical dialogue management. You chat with like some companies online, help bot, and most of them are like these kind of hard-coded things. So very easy to control and constrain.
But sometimes extremely frustrating.
Exactly. We'd all agree they're not very intelligent, and therefore, they don't really fulfill their mission. On the other hand, I can have a totally open-ended chatbot that talk about anything that seems like a human. It's so smart and can solve my, do my math homework problems and write me a speech and give me customer service in the form of a sonnet, whatever, right? But really hard to constrain. And so, there's like this spectrum in between. And obviously, we're not satisfied with AIs that are dumb but trivial to constrain. Because if we were, we wouldn't have invented large language models and the world wouldn't be excited about this. So it's really that, like, how do you take this thing that's very intelligent and very flexible, but also constrain it? And again, I just come back to this, like, we figured this out with humans.
Yep.
Companies employ lots of humans. And for the most part, you're pretty confident that your humans are in fact following your policies. That's not a thing that's like keeps CEOs up at night, that what if my employees don't do what I tell them to do? I mean, it's not easy, but it's tractable. And I don't see any reason why the AI version of that is any less tractable.
Yeah, makes sense. So it starts with the putting the controls and guardrails and observability in place to get.
These are all very important ingredients. Absolutely.
Exactly. Yeah, absolutely. Awesome. So maybe we can switch gears a little bit. So today, I would say maybe in the last 6 to 9 months, there has been a lot of talk about agentic AI, right? And so if you kind of think about the evolution of generative AI in the enterprise, there's people started a lot with RAG and then fine tuning, but still I think a lot of 95% of AI, Gen AI apps people are building are still RAG, but then there's no agentic workflows have come about. Could you talk about what you're seeing there and what is this agentic workflow? How does it differentiate with RAG, and how do companies need to think about,
Well, they're very similar. I think what people call agentic workflows are just a generalization of, and I should say RAG, retrieval augmented generation. Mm-hmm. So the idea, maybe I should explain what these all mean. So the idea of RAG, retrieval augmented generation, is, what is an LLM? It's a very philosophical question. So LLM is some fundamentally neural network, typically transformer-based neural network, that's been trained on a large amount of text, human text usually. And what it does is it learns the structure of that human text. And the way it learns the structure of that human text is it memorizes a lot of things, a lot of, that a mother and a father are related, and they're different genders, just like a king and a queen are related, but they're different genders. And that I don't know, France has a capital called Paris, and that, like, there's just tons and tons of facts that are in our heads that allow us to communicate. And these LLMs have memorized so many things. Sometimes they memorize specific facts. A lot of times they memorize sort of conceptual facts. And so when you ask it a question, it'll, in its sort of vast memory that's encoded in the weights of the neural network, it'll spit out an answer. And oftentimes those answers are plausible but totally made up. And people refer to this phenomenon as hallucination or confabulation. And so that's not very useful. I have this thing that sounds really good and speaks my language and can't be relied on to actually tell me the truth, because everything it says sounds plausible. And that's just kind of inherent in how large language models work. And so then people said, well, okay, but what if I actually have facts? I have like Wikipedia. I'll consider Wikipedia to be the ground truth. Mm-hmm. And instead of just asking my large language model a question, I will first find relevant passages from Wikipedia, let's say, that are likely to have facts relevant to the answer. And I'll prime the large language model. I'll say, hey, large language model, here's a bunch of facts, articles from Wikipedia. Here's a question, now answer it. And what you find, it's like intuitively makes sense, is that the large language model is much more likely to use the facts in the passage that you fed it rather than make them up. And so this led to this idea of retrieval augmented generation, where when you interact with a large language model, the first thing it does is it goes retrieves a bunch of hopefully relevant information somehow before it answers.
Yeah.
And this makes a lot of sense. And most LLMs that I've seen deployed in production are retrieval augmented in this way.
Correct.
But then people started to think, well, if I have this large language model that's like retrieving information, maybe the thing I ask it is, what time is it in Paris? Well, that's not stored in a database. To find out what time it is in Paris, it needs to, like, first of all, realize that I'm asking it to go look on a clock somewhere, figure out what time zone am I in, what time is it right now, do the translation and answer. So that's like, on some level, it's retrieving information, but it's not retrieving it from a database or text. It's using a tool, looking up, your geolocation, looking up the current time, all these sorts of things, right? And so what started as RAG systems kind of evolved into this more general notion of, what if I just allow my AI to use tools to call other systems, computer systems, to get information? And maybe those other computer systems themselves are AIs. I have an AI that's specialized in figuring out what time it is. It's all this AI does. And it has access to clocks and whatever. And my master AI, or I don't know what you call it, my front level AI, gets the user's question and says, oh, I don't know how to answer this, but let me go ask the time AI, because it's good at this, right? And so now, instead of one AI that, go back many steps in my story, one AI that's just memorized a bunch of stuff and maybe makes things up, I actually now have a network of AIs that are all experts in their different domains that themselves may have access to external tools or facts or databases or whatever. And this is now what we call like an agentic system, because it's made up of these agents. And it's a very natural evolution, I think.
And so the communication is happening through these unstructured interactions between these agents.
Very interesting. Yeah, I think that's right.
It's almost like humans speaking to each other in a workplace, basically.
I just keep coming back to this idea of the future, like the history of computers is APIs, application programmer interface, application programming interface, where you have a structured way of sending a request to a computer program to get a response. I form my packets this way, JSON, we have all these formats and YAML, and HTTP, whatever it is, all these structured ways of things communicating. And now we're kind of saying, well, it turns out that we have computers, we have automated systems that are pretty good at just speaking human languages like English. So instead of formulating my request to it in a very structured way, I can just kind of talk to it in English. And it is funny to imagine you might have all these agents, that are communicating, speaking English to each other. And that's super interesting, because now all the problems I had in monitoring and security and logging and guardrails, I actually probably want to start to monitor the communication between my agents.
Yeah.
Using all the same tools. So my example earlier, I said, I have a customer-facing chatbot. Customer service chatbot. So I have a human talking to an AI. And we want to monitor it. We want to say, what is the human saying? What's the AI saying back? Compliance and on topic and all these kinds of things we care about. Well, now I might have a human talk to an AI, and then that AI goes and talks to a bunch of other AIs, maybe in English. And maybe those AIs talk to other AIs in English. And maybe one of those AIs talks to a computer system in JSON, right? But I have many links in these communication chains, and I probably want to monitor all of them. Because
you need to put those safeguards and controls in place.
That's right. What if this AI starts speaking in poetry to another AI, or somehow, it's plausible, right? But this AI starts doing something anomalous and interacting with other AIs in the system, and now I've got a whole bunch of AIs doing weird anomalous things. I really want to know that happens, right? And it should be doable, because you'd expect these agents, as I've described them, they're pretty specialized. If this agent talks to if my front agent talks to my time-telling agent and starts asking it about the weather, that probably doesn't make a lot of sense. Or if it starts speaking in rhyme, that probably doesn't make a lot of sense. Or I'm expecting it to send requests in JSON, and it starts sending not in JSON. that's probably a weird thing that I'd want to have an alert flag and I want to go debug. Well, what happened, right? So I
But
think
those connections are still being done by the humans and programmers today, right? Like
today,
which question to route to which agent and whatnot. But in the
absolutely,
future, that can get autonomous
even
and things
that,
can be,
absolutely, all these things. And I think, testing these systems is going to be more complicated because you can have much more variety in the kinds of data flow. I send a request in, and the communication pattern could have a lot of variety based on what the request is. So kind of asserting that things look right, I think will get harder and harder, which means, again, that your monitoring needs to also be pretty flexible and probably fuzzy. And so again, I think that the technology that's kind of underlies NeMo Guardrails, which is dialogue modeling, I think it's probably the right paradigm for this future as well. But again, tools like Fiddler, observability monitoring, super important. Anomaly detection, these things are super important, and will be even more important in the future. There's this concept in programming, people, software engineers in your audience might know, called pre and post conditions. So this is kind of like asserts in languages where you say, I'm going to call this function, and there's some conditions just logically that must be true. My computer is a giant state machine, and the state of the computer at the time that this function could be called should have this, and this true. And I typically code these as asserts. And at the end of this function, I should have these conditions should be true. And inside the function, these conditions should be true, right? And this is like absolutely like a best practice from a software engineering perspective, because most bugs, almost every bug, is your system is in a state that you didn't expect it to be in. And all these asserts help you find these. I think these agentic systems, they're computer systems. They also have states. Now, the states are much fuzzier and more amorphous and complicated. But I think that the future version of pre and post conditions is going to be some form of guardrails, monitoring, alerts.
Yeah, absolutely. So I think it seems like there's a question from the audience, which I think is related to what you just told. The question is from Philippe. Finally, where do you see the role of AI agents evolving in the next 5 to 10 years? Do you envision them being fully automated in critical sectors, and do you anticipate ongoing human oversight as a necessary for safety and alignment?
So that's honestly a more policy question than anything else. We already have computing systems that are, autonomous in some ways, right? Think of just like software that you run that, I don't know, like my spam filter. It's pretty autonomous. Like I'm not tweaking my spam filter. I just trust it. Now, sometimes it gets things wrong. So do I every once in a while go check my spam folder? Occasionally, less and less. 10 years ago, I would have done it a lot more. I trust my spam filter a lot more now. So I kind of check it less and less, right? But I think that's an example. We're surrounded, like I feel like we look towards this future. It's like it's going to be wild, but a lot of these things we already live with, right? But I think the question is getting like a deeper question. Is more and more of the world going to be automated away from us in a way that will be increasingly opaque to humans? I think that's dangerous, right? I think there's like a lot of value in human oversight for all kinds of reasons. And I think compliance is going to force that, until you're really confident in the technology, you're going to have humans overseeing things. And, what does it mean to be really confident in technology? I don't even know. I guess I don't want to mention specific industries, but there's a lot of things. It's hard to imagine, any responsible company would allow an AI to go execute something without human oversight, some critical business function without human oversight anytime soon. Will it happen eventually? Gosh, I couldn't answer that question. But I think over the next, let's say 5 years, I don't even want to give a time horizon, but in the medium term, 5-ish years, I think what we will see is a lot of the rote work that we do that's time consuming be automated. And the role of humans will be overseeing a lot of this kind of work and checking. Like my example earlier on checking, a reimbursement receipt, for compliance. That's something humans do today that requires kind of human cognition and brain power, or has required human cognition, brain power. But you could totally imagine that an AI would be pretty good at doing that task. Would it be 100%? No. Is there a risk of it not being 100%? It's low. Like if that AI gets it slightly wrong, well, there's probably an appeal. The person who filed for that reimbursement might say, hey, the AI rejected me, and then a human would step in. So I feel like you can imagine how a lot of these processes could start to be automated, and you can also imagine how human oversight, isn't going away anytime soon, right? That's kind of the future I imagine in the next couple of years.
Awesome. This is great. I think we've touched upon the past, the present, and the future a little bit. But maybe we can get back to a little bit of success stories, and especially going back to the NIM and the NeMo stack that you're building. Could you share like a success story of some of these projects that have impacted our customers' AI capabilities in the recent past?
Sure. Yeah. So, I mean, one of our earliest successful customers is Amdocs. So Amdocs is a very large company that is a service provider to the telco industry. So a lot of like the bills that you get from Verizon, or maybe I shouldn't mention companies because I'm not actually sure who's their customer. But when you get your cell phone bill, a lot of times it's actually processed using Amdocs software.
Yeah.
Customer service, they do a lot of the software that runs the telco industry is operated by Amdocs. And so they've been a very early and great partner of ours adopting NIMs. We have something called NeMo Retriever, which is a collection of retrieval models so in this RAG system, retrieval augmented generation, there's this question of how do you retrieve information? How do you find documents that are likely to be relevant to the conversation that you're having with your AI? And so there's AI models that do that. And so we have something called NeMo Retriever. And so they've used NeMo Retriever and NIMs, and they built a bunch of different RAG systems, and they've seen huge success. So I think the number they told us, we have a blog post about this on our technical blog on NVIDIA.com, but the numbers they told us was, I think, an 80% reduction in latency versus deploying a comparable system using all of the various managed services that were out there. So what they really wanted was, rather than hitting all these different endpoints managed by different service providers, on different networks, wherever they may be, they just wanted to take all the models and run them themselves, hit the endpoints on their own infrastructure. You reduce network latency. They could ensure they had, optimal size models. They had control over what the models were, how big there's always a trade-off between a bigger model, which is higher latency and slower, is more accurate, versus a smaller model. But maybe it's overkill for this one thing, or I could take a smaller model and fine-tune it and make it really good at this one task. And even though it's smaller, it's actually more accurate than a bigger, more generic model. So all these kind of factors. And so they did a lot of this work with our help. They saw an overall end-to-end reduction of 80% in latency while no loss in accuracy or quality. I think their cost, it was like a 60% reduction in data pre-processing cost and a 40% reduction in inference time cost, if I'm getting those numbers right. So, and it just makes sense, right? Deploying all this, being able to optimize the models and deploying on an optimized infrastructure is going to have benefits. And I think they're a great example of a company that has a real production system with demanding customers, and they deployed it, and they're seeing some really great results.
Awesome. This is great. Thank you so much, Jonathan, for being on this session. I learned a lot, and from all the way to how the NVIDIA AI strategies in building these Lego blocks to fine-tune, prompt engineer, build RAG applications, and also inference them at scale, and also the guardrailing aspect of it. And I think what we are seeing honestly in enterprise use cases, whether it's banking or financial services, people are building these internal search applications, Q&A applications, customer service. These are some of the dominant generative AI applications. And this aspect of the things that we talked about, security, guardrailing, inadvertent keywords showing up, or topics that the chatbot should not mention that are coming through, and then just the sheer accuracy of these LLMs are really top of the mind issues. We are very excited about the partnership that we have. So if you are thinking about NeMo Guardrails, like many of our customers do, you could integrate Fiddler with NeMo Guardrails for monitoring and also get the guardrailing and all the rules framework that NeMo offers today. And thanks everyone for joining the session today. Hopefully you found it interesting. If we are going to publish this video later on our YouTube channel, and also a podcast will be available. That's it for today. Thank you so much, Jonathan. Thanks again.
Thank you. This was a really enjoyable conversation. Yeah.
Awesome. Thanks.